Hello, everyone. I want to walk through how to solve this week's challenge problem, which is given an array of non-negative integers, return an array consisting of all the even numbers of A followed by all the odd numbers of A. So if we have 3, 1, 2, 4, we need to write a function that returns 2, 4, 3, 1. It doesn't necessarily have to be 2, 4. It could be 4, 2, but just even numbers, then odd numbers. So I want to show multiple ways to do this. Evens, odds, and then array that takes in A. A is going to be 3, 1, 2, and 4. So, and because I'm going to be a good programmer, I'm going to make a nice docstring function that sorts array with evens in front and odds at the rear of the array. Args is going to be A, and this is going to be as the array to sort returns it's going to be returns an array that is sorted with evens in front and odds at the rear. So first, I'm going to make a list of even numbers and for odd numbers. So empty list of evens equals this, odds equals this. And then I'm going to loop through my array for x and a. And I want to check if each number is divisible by 2. If it's divisible by 2, add it to the evens list. If it's not, add it to the odds list. If x%2 is equal to 0, evens dot append x. And then if it's not divisible by 2, we're going to add it to the odds list. And then finally return evens plus odds. So evens, odds, and then A, 2, 4, 3, 1. So cool. Nice thing about adding that nice doc string is if I do shift tab, it'll show everything about this doc string and it puts it in a nice format. So I think it's kind of nice. So cool. Now I want to show another way. I'm going to do this with list comprehension now. So I'm going to copy this over because I'm going to be using the same doc string, but with list comprehension this time. Comprehension. I didn't spell that right, and that's going to bother me. Comprehension. I don't know how to spell comprehension off the top of my head, unfortunately. So there we go. Cool. So now I want to use list comprehension. So evens is going to be for x and a if x %2 is equal to 0. I want x. And then for odds is going to be the same thing for x and a if x modular 2 is not equal to 0. I want x. And then return evens plus odds. So evens 2, 4, 3, 1. So cool. The next way that I want to do this is using pop. So define evens, odds, pop. I think showing multiple ways to do something is really valuable in like a technical setting. You show all the cool things that you know. So the first thing I want to do is make a copy of my array. A dot copy. And then I want to loop through my array for x and a. And then I want to check if the number is an odd. If it's an odd, I want to remove it and add it to the rear of the list. So if x modular 2 does not equal 0, I want to remove that number, and then I want to add it to my B list. So it's going to add it to the rear. So plus equals num, and then return B. And it does not like that. So it's mad about line 12. So line 12 is this one. Maybe I need to add. Oh man, I forgot my if statement. If evens, odds, pop A, and num, I want X, not number. So 2, 4, 3, 1. All right, cool. So now let's see which one is most efficient time-wise. So how do we decide? This is one way. So time it will run. So if I do percent time, evens, odds in A, and let's do percent time, evens, odds, list comprehension A, and then percent time, evens, odds, pop of A. So this, they all took, so 10 microseconds, 11 microseconds, 11 microseconds. If I run this again, 13.1. So there's a little bit of variance to it. So time it will run a bunch of loops. So I usually like using that if it's not too big of a function. So let's run this because it does take a little bit long to run. So the reason it took so long to run is we are doing 1 million loops for 7 different times, so 7 million runs. So this took 718 nanoseconds. This took 1.06 microseconds. This took 759 nanoseconds as well. Yeah, so that's one way to kind of test it out. Yeah, hopefully that was useful, and let me know if you have any questions. Thank you.